Hey, it's Dr. J. Today we're going to start studying algebra, chapter 2, section 1, the language of algebra. And we'll just go ahead and get started with some very important vocabulary. Now, I don't expect you to memorize all these words in 5 minutes, but I'm just going to put them all out there, and then throughout the rest of the lecture, in fact, 2.1 and 2.2, for that matter, probably the rest of the semester, we'll be using these words, periodically, quite frequently, in fact. So we'll start off with the symbols. So we have addition symbol. That one's pretty obvious. Subtraction symbol. Minus sign. Multiplication symbol. Now there are several different multiplication symbols. Probably the oldest one you remember from elementary school was the X, and we use this in chapter 1. But because we're going to be now studying algebra, we omit the letter X because it's misleading. So we're no longer going to use the letter X for multiply. Now, I shouldn't say that so strongly. Occasionally, we still break it out if it's not going to cause any kind of confusion. So we replace it with a dot, a multiplication dot, or parentheses to represent multiplication. Okay. I will come back to the multiplication symbols later. It turns out as we move forward, you can even have no symbol at all. And that might come a time where we just don't even use a symbol at all, and it's understood to become multiplication. Division symbols. We have several or a couple different division symbols. We still use the old school division symbol. That one doesn't really get omitted. It's rarely used, but we still have it. Or we'll use a slash for a quotient for divided by. The slash could also be horizontal, something like that. Really depends. If you're trying to save space, sometimes we write it at an angle. But if you've got plenty of room, we sometimes write it like this. Okay. And it would kind of have, a number in the top and a number in the bottom, or maybe something like this. Okay. Now, the key here is that when I say addition symbol, I'm talking about the actual symbol that we're talking about, not the actual operation or the result of the operation. So the result of addition is called the sum. So again, we don't say that the symbol is called the sum. The symbol is just called the symbol, the addition symbol, but the result, after you've actually done it, we call that the sum. The result of subtraction is called the difference. The result of multiplication called the product. And again, when I say the result, what I really mean in everyday language is the answer. Yeah. So after you've done the math and what do you actually get for your answer, we call that the product. And the result of a division problem is called the quotient. Okay. So those are going to be your 4 basic operations and the vocabulary words associated to them. It does take up quite a bit of space. A variable is a letter used to represent a known or unknown value or number. For example, probably the most common, x. So we would not want to use x as multiplication in this lesson. We would want to use it as a variable. X, y, z, a, b, c, etc., etc., etc. There's basically only one letter we don't use, and that's O. And I think it's probably obvious if you use O, you're not going to know, is that a 0 or is that an O? But basically, you have all 25 letters at your disposal to use as variables. An expression is a combination of variables and or, so you can have one or the other or both, and or numbers with mathematical operations. And when I say the mathematical operations, I mean the ones that I just discussed a minute ago: addition, subtraction, multiplication, and division. Eventually, probably on the next lesson, we'll get into exponents and things like that. Okay, let's see if I could fit this in here. An equation is a mathematical sentence containing an equal sign. So we have expressions. Notice expressions do not have equal signs. So if it has no equal sign, it's an expression. If it's an equation, then it definitely has an equal sign. See, equal equation. All right. We're almost done with the vocabulary. I'm just going to get it all out there, and then as I'm teaching, you'll hear me say these words over and over again until you start to get used to them. If you want, you can make a little cheat sheet that kind of has them written down for you, or when you do your homework, you can quiz yourself on these. A coefficient is a number that is multiplied by a variable. For example, 5x. The coefficient is 5. The variable is x. Now, this is what I was mentioning earlier. When we say 5x, it is implied that this is multiplication. So multiply is implied. In other words, it's not necessary to put parentheses. It's not necessary to put a dot. But it is correct. So 5 parentheses x means the same thing as 5 dot x, but that also means the same thing as just 5x. Right? Multiplication is the only operation that's implied, where you don't have to actually say it in order to mean it. Yeah. Okay, that ought to do it for now. I don't want to get too many words out there, but as we go through chapter 2, we'll throw out some more words. We'll come back and review the definitions of these words when it becomes necessary. Let's go ahead and start doing some examples. So what we're going to be doing is translating into equations or expressions. Let me say expressions first, or equations. Okay. And then I want to make sure that before I do any problems, I just want to make a point. Be careful with the words less than. The words less than are one of the mathematical phrases or translations that we're going to be doing that can be ambiguous. You might interpret it one way, but it might actually mean something else. So it can be confusing sometimes if we're not careful. So look for the word is. Okay. So let me give you an example. Translate 10 is, I'll just use the number, 4 less than 14. 10 is 4 less than 14. So in this particular instance, less than means subtract. Is means equals. And then you have to be very careful. You're going to subtract 4 from 14. So you have to reverse the order. So 10 is 4 less than 14. Now let's compare this with something like this. Ten is less than 14. It means something different now. Now it means inequality. An inequality symbol looks, we used to call these alligators or crocodiles. And so now it's not an expression, it's not an equation, it's neither. It's an inequality. So it's not an expression. It's not an equation. It's a special category called inequality. Now, I'll give you the good news and the bad news. The good news is we're not studying inequalities today. Okay, I'm just putting it out there because you're going to see the word less than throughout the homework and throughout the assignments. The bad news is someday we're going to have to deal with this. We can't just ignore it forever. So for now, we'll just put this inequality on hold. We'll say there is a thing called an inequality, right? It sounds a lot like subtraction, but it's not. It means something different. All right. And then if we have an unknown value, say 6 less than a number. Right. And again, I'm saying less than, but notice there is no is. You don't see the word is. Okay. So a number is going to be a variable. If you're when in doubt, just use x unless told otherwise. Yeah. You can actually use any letter you like, but there are some problems in the homework that specifically tell you what you have to do. And then 6, well, 6 is obviously 6. It goes over here. And then less than now means subtract. So notice the difference between an inequality less than, is less than, and a subtraction less than. It's all about whether the word is there. This is an expression. Yeah. How can you tell? Well, it's not an equation. Yeah, because it doesn't have an equal sign. Yeah, so we know it's not an equation. So the way this is going to go is we're going to spend some time translating expressions, and then eventually we'll get to solving them, simplifying them, and things like that. Well, we'll simplify expressions, we'll solve equations. So here we go. I know it's a lot of words. Write an expression for Dave's height. Probably take me longer to write the questions today than it will to actually complete them. So we got Dave is 8 inches taller than Sarah. Let H represent Sarah's height. Find an expression for Dave's height. So H is our variable. Since it told me to use H, I'm just going to use H. And then 8 inches taller would be H plus 8. Since it says expression, we're not going to put an equal sign. And we're not using a variable for Dave. This is Dave. This represents Dave. Dave's height. So Juan spent $2 less than Steve at lunch. Let S represent the amount Steve spent. Find an expression for Juan. I know I'm running out of space. It's kind of hard to see what's going on here, but let's see if I can get that in there. Sometimes I try to squeeze 2 problems on the board and then I regret the choice. So we're trying to find an expression for Juan. Juan spent $2 less than Steve. So S is going to represent how much Steve spent. We're finding an expression for how much Juan spent. He spent $2 less on lunch, so S minus 2. This would represent Juan. And again, we're not making variables for both characters here. We're just making a variable for the one that we're instructed to. So in this case, s. Now you got to be careful with sloppy s's. Sometimes they tend to look like 5s or something like that. So I'll leave that to you. Jake studied Y hours for a test. Jill studied half as long. Write an expression for Jill. Well, it's for how long Jill studied. So this one has actually multiple answers because we're cutting something in half. So one possible answer would be y over 2. Yeah. Jake studied for y hours. That's our variable. Half as long, so y divided by 2. You could also write it with the old-fashioned division sign, but this is very rare. But it still exists. It's rarely seen. It's not on your keyboard. I've always wondered why. Yeah. You ever looked at a keyboard? You've got almost every symbol, but you don't have this one. It's just not there. Another option would just to say 1/2 y. Yeah. Or you could say 1/2 parentheses y. Or you could say 1/2 dot y. All of these answers would be correct. I probably would just go with this one. Simplified. Yeah. But they're all correct. Yeah, we have to mark all of these correct because it means half. I could also break out some decimals, but I'm not going to, not in this chapter. On a test, Dave tripled his score from the previous test. If T represents the score on the previous test, what is Dave's new score? In other words, on the second test. So we've got T. That's our variable, T. Notice how I write it with a little hook so it doesn't look like a plus sign. If you write your T like that, it's going to look like a plus sign, and you might get away with it once in a while, but one of these days it'll get you. So you can either do that or you can do like a capital T or something like that. Fortunately for you, you're doing a lot of typing, so I wouldn't really worry about that. All right, so remember, doubled is multiplied by 2. 2 times something. I know I don't need to say this, but tripled means multiply by 3. Quadrupled means multiply by 4. I'll stop here. Quintupled means multiply by 5. And so we are tripling. So we're going to multiply the old score by 3. That's your answer. Tripled. I'm going to give you all the words, doubled, tripled, quadrupled, quintupled, because it sort of randomly generates the word in the question. Sometimes your question might say doubled, other times it might say quadrupled or something like that. Quadrupled. It keeps going. You can go sextupled and septupled and octupled, but we're not going to go there. Double, triple, quadruple, quintuple. Good enough for us. Mr. and Mrs. Smith were driving to a meeting 210 miles away. If Mr. Smith drove the first D miles, how far, and Mrs. Smith drove the rest of the way. Told you it takes me longer to write these questions down than it does to solve them. Mrs. Smith drove the rest of the way. How far did she drive? So you could just write down the answer if you already know it. You got D miles, you got 210. You could just mental math it and see. But sometimes when the problems start to involve physical quantities and things that we can drive out and go, well, 210 miles is the total trip. That's the total. All right. Mr. Smith drove D miles. So that's this amount here. So this is Mr. Smith. And then the leftover is 210 less D. Yeah. So take away D from the 210, and this tells you how far Mrs. Smith drove. Now, of course, you didn't need the picture to solve this or to write out the expression, but it certainly doesn't hurt. And we're going to eventually be doing geometry problems in which the picture does really matter. So just trying to plant that seed. Now we'll water it. Manny is not 2, 6 years less than twice Nick's age. Write if N represents Nick's age, write an expression for Manny's age. All right. So we have N as our variable. This one's getting a little tougher. 6 years less than twice Nick's age. So we're going to do double Nick's age. Twice means double. If you really want to be safe, you can put the multiplication dot on your keyboard. It's like a star. What is it? Shift 8. Or there might be a little pop-up menu with the dot. And then 6 years less. So subtract 6. And if you like, you can omit the dot and just say 2n minus 6. Or not. You could leave the dot if you like. Okay, we're almost done with the translating. I got a few more vocabulary words to do before we do the next problem. Next, we're going to talk about exponents, also called AKA powers, also known as powers. So if you raise something to the second power, this is called squared. Or you can say to the second. Either way you like to say it. Try not to say this, x2. That will cause so many problems, not just in my class, but in every other math class you ever take. So you do not want to call this x2. Right? It's x squared or it's x to the second power. Cubed, x to the third power. And then after that, we just say to the power. We don't have a fancy way of saying it. So anything larger than 4 or larger, we just say to the fifth power. And I'm going to stop there and just say this is the pattern. All right? The real important ones, the ones we see all the time, are the squareds and the cubes. I mean, I'm not trying to imply that the other ones aren't as important. I'm just saying that these are the ones that have the kitschy words, you know, squared and cubed and things like that. Okay, so let's do some problems with exponents. Write an expression. Do not evaluate. In other words, do not tell me what the actual answer is. Sometimes evaluating is just thought of as doing the math. So I'm saying do not evaluate. Just write an expression. Here, let's do a couple of these. All right, so what do we got? 5 times 3 squared. So 5.3 squared. And don't do the math, just leave it in that form. If there are no variables, any problem that does not have a variable, the multiplication dot is required. And you can see why, I hope. If you don't put the dot, it looks like 53. Yeah, looks like 53. So you got to put the dot, because you don't want it to look like 53. All right. This next one, 6 times 2 to the 5th. So 6.2 to the 5th power. And again, you don't have to do the math. This would be a pretty big number. Well, it's not that bad, but yeah, this one would be what? 45 or something, and then this one would be, I don't know, 200 and something. I don't know. Whatever 32 times 6 is. Okay, I think that'll do it. For the rest of the problems, we're going to evaluate. So evaluate means to do the math, find the value, simplify. All of these things are synonymous. So I say evaluate, you say do the math, find the value, simplify. Some people will say calculate. It's another way to say it. So these are all synonyms for evaluate. Now, there is some ambiguity. It's supposed to be a 1. So here's an example of an ambiguous expression. Okay? And let me explain what we mean by that before I actually do the math. If you were talking to somebody on the phone, all right, and you said, all right, can you calculate this for me? Maybe you're driving or something like that. No, you're not driving because you're not supposed to be on the phone when you're driving. So your hands free. You're talking to somebody. And you just tell them verbally over the phone, 4 plus 15. And the person just starts thinking, okay, 4 plus 15 is 19. Then divided by 3. Okay, 19 divided by 3. Don't worry that it's a fraction. It comes out. Then times 2. Yeah. And then finally, when you're done, subtract 1. Right? So that's the way this statement would read if you read it from left to right. Yeah. But that's not the correct value of this expression. So when we read an expression, sometimes we read it from left to right because that's just the way we read. And so it appears as if this statement is saying 4 plus 15 divided by 3 times 2 minus 1, but that's not at all what this is saying. This problem actually says 15 divided by 3, then times 2, then plus 4, then minus 1. Right? And you can't really tell that that's what that says because it's written out ambiguously. And so we follow an order. This is an agreement to avoid ambiguity. It's really so that everybody should be getting the same result. And you probably remember the acronym. P for parentheses. E for exponents. Oh, I want that problem. I'll do it in a second. What was it? It doesn't really matter. I just don't want to lose it. All right. Then we do multiplications or divisions. As they appear from left to right. So that's where we start going from left to right. All right. We don't take the problem right from the beginning and go from left to right. We do it as they appear from left to right. And then we do our additions or subtractions, again, as they appear from left to right. Okay. Now, in our book, it still uses the old PEMDAS. You might remember this from elementary school or middle school or something. Please excuse my dear Aunt Sally. But this acronym has sort of gotten outdated. And one of the reasons why we tend to try to not use this is it's not always parentheses. It could be any grouping symbol. Any grouping symbol. And then later on in algebra, it's going to be quite a while, but exponents could include roots also. Like square roots or cube roots or something like that. I wouldn't really worry too much about that in this class because it's going to be quite a while till we get to it. So when I say exponents, I truly mean exponents, but it could include some other type of root, 1/3 or 1/2, or even negatives and things like that. So having said that, now when we do this problem, I don't know if I copied it correctly, but it really doesn't matter. Evaluate 2 plus 15 divided by 3 times 2 minus 1. I think that's what it was, and again. So what are you going to do? There are no parentheses, so we'll skip that. There are no exponents, so we'll skip that. Now, multiplication and division as they appear from left to right. So you have to first do the division. So 15 divided by 3 is 5. Okay. And then do the multiplication. Okay. And then additions and subtractions, again, as they appear from left to right. So you want to go 2 plus 10, and then minus 1, and you get 11. Sometimes you can break that rule and still get the right answer, and that might tempt you to think that the rule doesn't really matter, but it does. Just always do it from left to right until you become an expert. When you become an expert, then you can, kind of manipulate it a little bit differently. All right. And you will become an expert eventually. Just keep on swimming. All right. So the rest of these problems are just going to be using the order of operations, and that'll wrap it up. Let's see how many we can handle. And these ones are a lot faster to write down. Okay. So here we go, 2 plus 4. Avoid that at all costs, all right? If you jump into a problem and you start adding right away, it's 9 times out of 10 going to be incorrect. So look inside the parentheses. Do whatever inside the parentheses first. So do all of this first. So you're going to have 2 plus 4. That'll be exponent, so that's 9. 3 squared is 9. Minus 4 divided by 2 is 2. Now keep going. 9 minus 2 is 7. Now you're going to multiply by 4. That's 28. And then finally add it up, 30. A lot of these problems didn't come out very well in my notes, so I'm just trying to be very careful that I write them down correctly. Here we go. So we often use staggered bracket, parentheses, sort of alternate. Brackets mean the same thing as parentheses. It's just a way of breaking it up for your eye. So you're always going to start with the innermost parentheses first. Don't do anything out here. Innermost parentheses, then exponents, so that'll be 16. Occasionally you can kill two birds with one stone if you can keep track of it. So maybe I could have done that already. 16 minus 3 is 13. Now be careful. Sometimes people will take the bait. I call that bait, 4 plus 2. But just hold off. Don't do it yet. 2 times 13 is 26. 15 minus 30. It's actually a negative 15. There should be no negatives. I told you if I look over my notes and I write one thing down wrong, it probably there should be no negatives yet. But I probably just wrote it down incorrectly, but I'm not going to redo it. The answer is negative 15. It's just a little early for negative numbers right now. We'll get to the negative numbers soon enough. All right. I'll tell you what. I'm glad this happened, because if this happens to you in this beginning section 2.1, then you definitely made a mistake. And you know, looking over here at my notes, I probably just wrote one of the numbers down incorrectly. So this would be a good clue about whether or not you've done it right or not. Now, once we learn about the negative numbers, then this would certainly be a possibility, but I think I just wrote it down incorrectly. So I'm going to try to end with one that's not a mistake, but sometimes we can learn from our mistakes. I learned to be more careful and write it down more correctly this time. This one definitely will not have negative numbers because I wrote it down correctly this time. All right, so again, don't take the bait. Stay out of there. Do the exponent, 8 plus 4. Still, don't take the bait. Just keep on swimming. 8 plus 4 is 12. Again, keep swimming. 12 times 3 is 36. All right, and now be careful. Go from left to right. So you're going to get 46 minus 3, which is 43. And that ought to do it. So welcome to the Language of Algebra. This lecture has a follow-up, 2.2. It's really just a continuation of the same thing. But I did break it up into a separate homework assignment. So until we meet again, I'll see you on the internet.